News live at AutoSens. We are here in Detroit at the Michigan Science Center for what has been an exciting week of ADAS and automotive thought leadership. Now, AutoSens is a best-in-class, world-class event that brings together the ADAS community. The industry experts that you see and meet here at AutoSens are helping shape the future of mobility. Today, we are joined by one of those experts, Daniel Shwartzberg, from Valens. Now, as a director of automotive system solutions at Valens, Daniel is responsible for ensuring customer success at the technical level, working with OEMs and tier ones worldwide on proof of concept and technical pre-sale discussions. Daniel brings more than 25 years of experience, predominantly with the semiconductor industry. Daniel, thank you for taking time out of your schedule and being here today.
Great pleasure. Thank you for having me.
So Daniel, give us an overview here. Tell us a little bit about Valens, and then just give us an overview of your role with the company.
Absolutely. So Valens is a fabulous semiconductor company. So we've been producing semiconductor solutions for high-speed wired connectivity since our inception.
Okay.
We actually started in the professional audio-video market, where we're the de facto standard for long-reach connectivity there, and ship millions and millions and millions of chips.
Sure.
And more recently, we took that same technology and adopted it for the automotive market.
Right.
We've had some amazing success. We're already on the road in mass production with Mercedes-Benz, and we have some more things in the pipeline as well.
Yeah, so that's exciting. So MIPI A-PHY, let's talk about this. You've made incredible progress already in the automotive market. It's a standard now for in-vehicle connectivity. But the question is, Daniel, why is the industry so eager to transition to this connectivity solution?
Well, as you quite rightly say, the industry is desperately eager to transition. And why is that? So first of all, until this point in time, the industry has been deploying single source proprietary analog SerDes solutions for their in-vehicle connectivity, for their cameras and for their displays and for other sensors.
Right.
Single source proprietary is not really the ones. They're looking for standardization.
Yes.
And MIPI A-PHY finally brings a standardized digital SerDes solution to the market with extremely high bandwidths. I mean, in its current version, A-PHY can run up to 16 gigabits per second on a single cable. And with extremely low packet error rate, we're talking about a packet error rate of 10 to the minus 19, which is several orders of magnitude more than what is available today with legacy solutions. Standardization also opens the door for integration. So in other words, we already hear public declarations from companies like Sony Semiconductor Solutions who are working on integration of A-PHY ports directly into their sensor modules. And that's good for everybody because that's going to reduce the size of the cameras, it's going to reduce the heat there. And also from, as I say, from a technological point of view, we've got long-reach connectivity on simple infrastructure, very, very high bandwidth.
Right.
And it's what the industry needs now. We're at this tipping point where to get forward, to get to those next levels of ADAS, to get to autonomy, we need more bandwidth, we need reliable data links, low latency data links, and A-PHY provides all the answers.
So you've got strong partnerships here in the industry. We've heard about OmniVision providing A-PHY support for ARDS. What other companies are working on A-PHY right now?
So the OmniVision announcement is fresh off of the wires, let's put it this way, just from a couple of days ago, integrating our A-PHY chipsets into their automotive reference design platform. And again, OmniVision, obviously an extremely large and well-respected camera vendor. So for us, that's a very big endorsement of the technology. But that's the latest in a long line of companies who have made public declarations.
Sure.
So we've seen it throughout the ecosystem on both sides and in between. We have, as I mentioned, Sony Semiconductors already talking about and working on adopting A-PHY into their sensor. We see Leopard Imaging, we see Sunny Optical camera vendors. On the other side of the link, we see companies like Mobileye throwing their weight behind A-PHY, putting it onto their reference design platform as well. We see tier ones like Aptiv, like Denso, also strongly endorsing this technology. It's providing them the solution they need to move ahead in the industry, to leapfrog their competition. And we also see, for example, even though wire harness companies, we see companies like Sumitomo, a very big Japanese harness and connector company, who also endorsing A-PHY. LG Innotek from Korea, do system in package modules. They've already said we're going to be providing A-PHY solutions as well. JASPAR in Japan, the Japanese standardization body, throwing their weight behind this as well. So we're seeing it across the industry. It's more evidence that A-PHY brings to the industry exactly what it's looking for, because the adoption rate of companies jumping on it is huge. And I can also tell you
Right.
that our engineering sample devices, our first generation of A-PHY products, we only launched those in December. We started shipping them on Christmas Day, and those are already in the hands of more than 30 OEMs, tier ones and tier two partners who are all rushing to evaluate A-PHY technology and the Valens chipsets. Huge industry ecosystem emerging and moving very, very quickly.
So congratulations on that
Thank you.
announcement from December. Let's talk a little bit more about the MIPI A-PHY compliant chipsets. Tell us more about the technology, but then ultimately, what solutions does it provide for the industry?
Very good question. So MIPI A-PHY defines speeds in gears. They call them gear speeds. So
Sure.
right now we have 5 gear speeds running at 2, 4, 8, 12, or 16 gigabits per second.
Okay.
There's a ton of bandwidth available for you right there.
Right.
MIPI A-PHY is a full stack solution implemented in the silicon. So from the physical layer right up to the application layer interfaces, it's all done in the silicon. It's all done in hardware. So it's extremely low latency. It's just a few microseconds.
Yes.
Critical for mission safety and mission critical systems where any delay in the sensor data reaching the processing could be catastrophic.
Yes, I see what you're saying. Yes.
MIPI A-PHY runs over long reach cables, longer than is possible with the competition. A 15-meter coax cable that can be broken down into segments with 4 inline connectors, or a 10-meter shielded pair cable.
Sure.
In addition, Valens chipsets know to work up to 4 gigabits per second on unshielded cable.
Okay.
And that is a huge cost saving to the industry. And don't just take my word for it.
Sure, sure.
A2Mac1, a well-respected international benchmarking firm, did a teardown of a European OEM surround view system.
Sure.
Comparing legacy analog SerDes solutions available today with future A-PHY solutions.
Okay.
Surround view system, and that move to A-PHYs they showed will give a total system cost saving of more than $16. In other words, more than $4 per link, which is huge.
It's huge.
And that is before we talk about integration of the sensor side of the serializer into the sensor, and then those cost savings will get even bigger. So we've got a lot of bandwidth, we've got low latency, we have this packet error rate I mentioned of 10 to the minus 19, far better than anything else.
Right.
That means that this technology is intended to be used for those most mission critical systems that are out there. We are ASIL B graded in terms of our functional safety, which also meets the requirements of the industry. And all of that bandwidth is from the sensor to the ECU. In the return channel, MIPI gives you 100 megabits per second with version 1 and 200 megabits per second with version 1.1 of back channel, which is just needed to configure and control the sensor.
Of course.
So the technology is fantastic. And I should also really mention that this is no longer just a MIPI standard. So good is A-PHY that literally 3 weeks after Spec 1.1, the launch of Spec 1.1 was announced by the MIPI Alliance, the IEEE announced that they would be adopting A-PHY Spec 1.0 as is, as a standard of their own. They have something called the Industry Affiliate Network, IAN program, which allows them to take technologies from other standardization bodies. And they rushed that process through in just a little over 6 months. And now A-PHY is not just a MIPI standard, it's now an IEEE standard. IEEE 2977-2021, if my memory serves me right. So the 380 members of MIPI is a big ecosystem of players, but now you have the additional ecosystem of all of those hundreds and hundreds of IEEE members as well. A huge ecosystem of players all supporting A-PHY.
Right. Daniel, everything we've talked about now, let's roll that up and let's talk about it in the context of a software-defined car. That is the software-defined car, big topic of discussion in the industry. So what is the connection between everything you've said about A-PHY, Valens, your strategy? What's the connection between that and software-defined cars?
So you're quite right. Software-defined vehicles, really, the big buzzword or the buzz saying at the moment. The idea being, of course, that you put out a hardware platform that then in future can be updated through software jobs and software over-the-air updates.
Right.
Now, in order to do that, as soon as the vehicle rolls off the production line and leaves the factory, it needs all of the hardware that it can do in order to support all those future software developments.
Yes, correct.
And that includes, of course, the in-vehicle connectivity, right? So you need a lot of processing power, you need a lot of sensors, and you need something that's a lot of bandwidth to connect between them, and that is where A-PHY comes in.
Right.
A-PHY is the ideal connectivity standard, the ideal connectivity solution to form that backbone platform, that infrastructure platform that the software-defined vehicles are going to need. Because without that, you're only going to be able to go so far.
Right.
And so you need high bandwidth, low latency, extremely reliable, robust links that can withstand the EMC electromagnetic noises that are generated within the vehicle. And A-PHY is ideally positioned to fill that role and to really become the connectivity infrastructure for the software-defined vehicles.
And if there's a cost benefit there, that's very attractive to OEMs who are trying to build vehicles at scale.
Absolutely, really. And I mentioned it earlier, our chipsets really can bring significant cost savings to the OEMs. Everyone's looking to reduce costs right now.
Yes.
And not just right now, they always have done and they always will do.
Sure.
And with A-PHY, you can use lower grade cabling, you can use simpler infrastructure, simpler connectors, and all of that helps us to keep the total system cost down. And with so much bandwidth available, you can even drive multiple sensors onto a single cable, so you can replace multiple links with a single link. And that's got to be good use for the industry.
This idea of a software-defined car, even as a consumer, is exciting to me. The connectivity, the more options, the in-vehicle experience will be so dynamic with a software-defined car. What you're saying, this is the architecture that makes it happen. This is the secret sauce.
And it has to be there because just like with your iPhone or your Android phone, whatever you've got, if you don't have the hardware there, you're going to run out of the technology in the phone to support the latest apps. And we see that after a few years, you need to throw your iPhone away if you want to run with the latest apps. And it's going to be the same with the vehicle. You'll be able to get so far with your software updates, and then you just got to run out of steam. So you need A-PHY, you need bandwidth, you need long length connectivity, reliable connectivity. And the Valens VA7000 chipsets, like I said, the first to market with A-PHY compliant products, are those are the devices that are going to be making that a reality.
Daniel, last question here before we wrap up the interview, and thank you for your time, of course. How did you get into automotive? How did you become an engineer, and how did you get into this business?
Wow. Well, it started a long time ago, as you can tell from the amount of hair I have on my head.
Yeah, right. I'm on my way.
Most of us are. So my dad was an engineer at Ford Motor Company for all his career in the UK. So I've been interested in cars since I was a very, very young man. I went on to university to study electronic engineering. I was sponsored through my studies by Ford. I began my career at Ford as an electronics engineer, loving every moment of it.
Of course.
At some point in time, I moved countries. I got into the semiconductor business. And what's lovely is now I've come full circle. I'm so excited to be back in the automotive industry, especially at this time, because so much is happening right now. Compared to when I left Ford, which was like some 25 years ago. When I think that back then we were bringing out products with CAN bus, and CAN bus was like the revolution. Look where we are now. It's incredible to see the shift that's happening. The companies that maybe have traditionally been very conservative and slow moving in their progress suddenly have completely shifted up a gear, and everyone's in a race to get the latest and greatest technologies. And I'm thrilled to be at Valens. I'm thrilled to be supporting these products. It's a terrific time to be in the industry.
It's well deserved, Daniel. Thank you for your time. From all of us here at AutoVision News and AutoSense, we want to wish you the best of luck going forward, and thank you for being with us today.
Appreciate it. Thanks so much for having me here.